Exponential function space e. A function of the form p of t equals p times e to the t is an exponential function base e. This number, this e here, it's not a variable, it's the number e. So 2 point, a bunch of things after the decimal point, it goes on forever. Okay, so just a quick note before we do an example. If you assume t is time, at time t equals 0, we're going to get p e to the 0, or p times anything to the 0 is 1, so we get p of 0 equals p. So this is actually the initial amount if you're doing a word problem, and t stands for time. So at time 0 we have p as our amount. Okay, let's do an example. If the amount in grams of carbon-14 present in a soil sample after t years is given by A equals 2.9 e to the RT, where R is negative 0.000121, then what is the initial amount of carbon-14 in the soil, and what amount is present after 6,500 years? Okay, let's start with the first question. Our initial amount if we take our equation, which is A equals 2.9 e to the RT, if we plug in t equals 0, which would correspond to the initial amount, how much we have when time is 0, we're going to get 2.9 e to the r times 0, or 2.9 e to the 0, or 2.9 times 1, which is just 2.9. So as I talked about earlier, this number, p, or the number in front of the e to the rt, that's always your initial amount. So this substance, carbon-14, we're measuring it in grams. So our initial amount is 2.9 grams. That's how much carbon-14 we start out with. Now our second question is, what amount is present after 6,500 years? So how much carbon-14 is in the soil after 6,500 years? So to do this part, we need to use our equation. So our equation is A is 2.9 e to the RT. Now we're told that R is a specific number. Let's look at it. It is negative 0.000121. And so our formula that calculates how much carbon-14 is in the soil is actually 2.9 e to the negative 0.000121 times t. Now, if we want to know how much is carbon-14 in the soil after 6,500 years, all we have to do is plug 6,500 into this equation. And then we can use our calculator to figure out what this number is. You should get about 1.32 grams. Now, this topic, radioactive decay, actually has some interesting applications. You can use this to do what's called carbon-14 dating, and that is figuring out how old things from a long, long time ago are by figuring out how much carbon-14 has, how much it has decayed in the object.